for that last problem on WebAssign, you had to first be able to calculate a heat of reaction. I know a couple people just looked up the heat of combustion for C3H8, but that wasn't exactly what was intended. Okay, so I want you to be able to calculate a heat of reaction. So the formula is very easy. The heat of any reaction is equal to the heat of formation of your products minus the sum, that's what that's supposed to be, a little summation sign, the sum of the heat of formation for your reactants. So in this one, it's products minus reactants. And hopefully as we do this, this will ring a bell. You did do this a lot in Chem 1. Okay, so I'm going to pick a reaction other than the one in WebAssign because I'm going to reopen that tonight. Okay? The first, let's see, let's do the combustion of octane. C8H18, where do we see octane or experience octane? In our gas tanks, that's right, okay? And when we combust, what are we adding? What are we adding when we combust things?
Oxygen.
Oxygen, yes, you're noting the octane rating, right? Yes. Okay, what are our products of combustion? CO2 and water. And what do you think the form of water will be? What phase? Yeah, probably a gas. We don't see water rolling out of our tailpipes because it's such an exothermic reaction that the water is going to be produced as a gas. So this is going to be a gas, this is going to be a gas. Oxygen's a gas, and this, ooh. Guys, see if C8H18 is in your book.
It's not.
It's not. Okay, we're gonna have, that would have been really cool to combust that, but we're gonna have to combust something that we can look up. Okay, so let's look under carbon. And let's find something with carbon and hydrogen in it. Let's do ethanol. C2H5OH. C2H5OH, and let's make it the liquid form. Yes, and that's important to specify. Okay, so this will be ethanol. Okay, and now let's balance our equation. What do I need to put in front of carbon dioxide?
2.
A 2. How about in front of my water? How many total hydrogens are here?
6.
There are 6, so what do I put in front of H2O? Let's do a 3. And so now we have 2 times 2 is 4 oxygens plus 3 oxygens. We need 7 oxygens over here. And do we want to change this number if we can help it? No, because we've already got this 2 and the 3 to help that. So let's see, how many oxygens do we already have here? 1. We've already got 1 oxygen, and so how many more do we need from here?
6.
We need 6 more. What number can I put in front? 3. And now we've got our balanced combustion reaction, okay? So now it's a simple matter of looking things up, but we're going to start with our products, okay? So we always have our products, all right? And then we're going to do our reactants. So I'm just going to try and color code these a little bit to help you. Okay, so the heat of our reaction, and specifically you could also call this the heat of combustion. That's just describing the type of reaction. So you can have heats of lots of things. So we're usually just describing your reaction. What we're going to do is we're going to look up carbon dioxide first. Guys, they're kind of alphabetized by the major elements. So look under carbon, and then see if you can find CO2, and it must be in the gas form.
Yes.
What is the number for CO2? Negative 393.5, and if you notice, the unit is kilojoules per mole. How many moles of CO2 are in our reaction? 2. And we are assuming that we're burning a whole mole of this. So I am going to multiply this by 2. Does everybody see why? This is 2 moles. That's what that 2 represents. So we have that twice. Then I'm going to add to it, that's what this summation sign means, let's add to it the value of water. Look under, it's either under H or, oh, I think it's under oxygen. Look under oxygen and tell me the value of H2O, but it must be the gas form. Negative 241 point what? 0.8, and let's just round it to 0.8 if you don't mind. And so this will be kilojoules per mole again. And how many moles of water did this reaction produce? There's our 3. Okay, and so for right now, these are our products. That is the sum of our products, okay? Then we are going to subtract the sum of our reactants, okay? All right, so can you guys look up C2H5OH and make sure you give me the liquid value?
Negative 235.1.
235.1, and that's kilojoules per mole.
Oh, no,
That's the gas.
Oh, that's the gas form?
277.7.
Okay. You know what? Sometimes making a mistake is better because now we know that we have to be very conscious of our state of matter and that a lot of times there are 2 values there depending on the state. How many moles of our ethanol do we have? I think I heard the 1. Okay, so you really don't need to do anything. I'm just going to be very deliberate. Okay, and then what is the value for O2? Do they even have it? Yeah, they do. It is 0. We'll talk about why it's 0. All elements are 0. Okay, and so how many moles of that do we have? We have 3, but it doesn't really even matter because it is a 0. Okay, so now we have all of our reactants. So we've got products minus reactants. If you guys could get out your calculators and find a total, that would be great. Maria, go ahead.